In this video, we're going to go over integration by parts. And so, understanding integration by parts, we first need to know the product rule of differentiation. So, when you've got the derivative with respect to x of uv, we know this is supposed to give us, first we're going to maintain v, we get to differentiate u with respect to x, and then we're going to maintain u and differentiate it with respect to x. Now, because we can see dx is common in everything that we have here, so we are just going to cancel it out. So we're going to remain with duv, and that is going to be equal to v du, and then plus u dv. Now, the integral of dx is x. The integral of dy is y. The integral of dt is t. Therefore, the integral of duv is going to be uv. So what I want to do is I'm going to integrate now everything here, and that is going to give us uv, and that will be equal to the integral of v du and plus the integral of u dv. Well, u comes first in the alphabet than v, so I'm going to make sure that I make this one a sub the formula. So I'm going to take this on the other side. That will be uv, and then it's going to become negative integral of v du, and that is going to be equal to the integral of u dv. So now, starting with this part, that will be integral of u dv being equal to uv minus the integral of v du. So this is the formula for integration by parts that we're going to be using. And now we just need to make sure that u is something that we can differentiate easily, and then dv is something that we can integrate also easily. So that is what we're going to take. And so, considering the first question here, evaluate the integral of x, 3x minus 2 to the power 4 dx. So from here, from the formula of integration by parts, the integral of u dv is going to be equal to uv minus the integral of v du. And so this one we've been given is where we get the first part, which is given here. And so we're going to make sure that we see what our u is going to be and what dv is going to be. Now, as I said earlier, u should be something that you can differentiate easily. So we have got a product of two functions here, x and also 3x minus 2 to the power 4. So which of these can we differentiate easily and which one can we integrate easily? Well, apart from knowing which one you can differentiate easily and integrate easily, you should also consider which one you can differentiate to get a constant. Here x can be differentiated to give us a constant. Therefore, I'm going to make it my u. So u is going to be equal to x. That means here dv is going to be equal to 3x minus 2 to the power 4. Now, whenever you talk of dv, it should always be related to dx. So we're going to get that one together with dx. And so what I'm going to do is I'm going to find du at this point. So du is going to be equal to, what will be the derivative of x? The derivative of x is 1. But every time we differentiate, we are going to add dx here. In other words, what I did is du over dx. That is going to give us 1. And I just get to cross multiply that. And now for us to remain with only v at this point, I'm going to integrate both sides. I'll integrate here and I'll integrate here. We know the integral of dv is a v, and so v is going to be equal to, well, to integrate this one, all we are going to do is get to add a 1 to the power. That will be power 5, and then get to divide by the same power, and then differentiate what is inside here. That will give a 3. So you get to multiply with what is in the denominator. Therefore, that is going to give us 3x minus 2 to the power 5 divided by a 15. So then we write the integral u dv is the question which we have itself. So that is x, 3x minus 2 to the power 4 dx. And that is going to be equal to u, and u in this case is x. V, where is v? V is this thing we've determined here, which is 3x minus 2 to the power 5, and then divided by 15. So following the formula, we've got a minus integral of v, and v is 3x minus 2 to the power 5 divided by 15, and then du. What is du? Du we can see is equal to dx. So from here we'll just simply continue simplifying. That is x, 3x minus 2 to the power 5 divided by 15, and then minus what? This 15 is a constant. I can remove it outside the integral, 1 over 15, and then you've got the integral of 3x minus 2 to the power 5 dx. And getting to simplify this, that will give us x, 3x minus 2 to the power 4 divided by 15. Okay, I've just changed this one. This is power 5, not power 4. And then minus 1 over 15. Now again we get to integrate what we have here. That will be 3x minus 2. Just get to add the 1 to the power. That becomes power 6. And then divide by the same 6. And then differentiate what is inside there. That will give us a 3. Multiply with what is in the denominator. Just add the constant c. So that will be the integral. Now just get to simplify it further. And that is x, 3x minus 2 to the power 5 divided by 15 minus 1 over 15, and then we have got 3x minus 2. This is raised to the power 6 over 6 times 3, that is 18, plus a constant c. So we can see something that is common here. 3x minus 2 to the power 5 is common also here, and 15 in the denominator is also common there, so I'm going to factorize out those which are common. So that is going to be 3x minus 2 to the power 5 divided by 15, and we are going to remain with only x on the first part, then minus this one has also gone. We can see the 15 is in the denominator there, so what will remain here is only 3x minus 2, and then that will be divided by what? 18, plus a constant c. So let's get to simplify this furthermore. And this is going to give us 3x minus 2 to the power 5 divided by 15, and then we have got, so we can say this is also over 1 and make it this single fraction, x times 18, that will be 18x, and then minus 1 will multiply 3x, that will be 3x, 1 will multiply negative 2, that will be also negative 2. Okay, like that. And then everything is going to be divided by 18, then plus a constant c. And so this is equal to 3x minus 2 to the power 5 divided by 15, and then 18 minus 3x, 18x minus 3x, that is going to give us a 15x, and then we have got a negative 2 there, and that will be over 18 plus a constant c. So that will be the answer. Another thing we can do is simply multiply this one and this one. Okay, so that is going to give us 3x minus 2 raised to the power 5, and then in the denominator, then if we get to multiply 15 by 18, that is going to give us 270, and that is going to be 15x minus a 2 plus a constant c. So this is going to be the integral in the very simple form that we can get to leave it. So let's go to the next one. Evaluate the integral of x e to the power x dx. So just like we did the previous one, the first thing we need to understand is the formula, because we are integrating by parts. So the integral of u dv is equal to uv minus the integral of v du. So in this case, what is u? U is something that we can easily differentiate, and if we can differentiate, at least we can even get a constant at times. So say let u be equal to x, and then dv is going to be equal to the other part which remains, that is e to the power x. Remember, dv should always be related to dx, and so we're going to find du. Du is going to be, what's the derivative of x? That is 1. So just put dx there because it was supposed to be du over dx. And then to remain with v, we're going to integrate both sides. the integral of dv is v, the integral of e to the power x. When you are integrating e to the power x, simply differentiate the power. That will give us a 1. That answer that you get divided by the of this function. Now e to the power x divided by 1 is simply itself. And so we'll now get to replace in the formula integral of x e to the power x dx. That is going to be equal to, where there is u, we are putting x. And then where there is v, we are putting e to the power x. Minus integral, where there is v, we are putting e to the power x. And then where there is du, what is du? Du is equal to dx. So we're going to put dx there. And that is going to give us x e to the power x minus, what is the integral of e to the power x? Well, that is also e to the power x. And then just get to add the constant c. We can just factorize out what is common, which is e to the power x, and that will remain x minus 1 plus a constant c. So that is going to be it for that one. Another one here, evaluate the integral of x sine of x dx. And same, using the formula, the integral of u dv is equal to uv minus the integral of v du. So which one of these can we easily integrate? Which one can we easily differentiate? At least the one which we can differentiate should give us a constant if possible. So u is going to be equal to x, and then dv is going to be equal to sine of x dx. Now I'll just put a very simple table here. Take the positive x-axis as sine, negative x as negative sine, positive y-axis as cosine, and then negative y-axis as negative cosine. As you get to move in the clockwise direction, then you are integrating. Okay, so here we're going to find du. The derivative of x is a 1, so simply say dx. So because du is going to be 1 dx. And to us to find v, we are going to integrate both sides. So integrate here, also get to integrate there. And what is the integral of sine? We can see the integral of sine is negative cosine. So that will be negative cosine of x. And then we go back to the formula, the integral of x sine of x dx is going to be equal to u, and u in this case, so we're substituting there, u is x, and then v, we found negative cosine of x minus the integral. V is negative cosine of x, and then du, we have found that it is equal to dx. So get to substitute where there is du, put dx, and this will give us, I can multiply this negative, that will be negative x cos x minus, well, this minus and this minus can multiply to give us a positive, and we're going to just remain with positive integral of cosine of x dx. What is the integral of cosine? We can see the integral of cosine is sine, and so that is going to give us negative x cos x plus sine x. We'll just get to add the constant c, so that is going to be the integral for that one. Let's consider question number 4 here. Evaluate the integral of x squared e to the power 3x dx. So again, which one can we easily differentiate? Well, x squared can be easily differentiated, and e to the power 3x can be easily integrated. So let u be equal to x squared. Then dv is going to be equal to e to the power 3x dx. So here differentiate u, that will be 2x, always don't forget the dx, and then v is going to be equal to what? So we're going to integrate both sides. Okay, so the integral of dv is v. The integral of e to the power x, simply differentiate the power, that is going to be 3. So this will be e to the power 3x, and then that answer that we get after differentiating, we divide by it. So write in the formula, the integral of u dv is equal to uv minus the integral of v du. And so this is the integral. The equation we've been given is x squared e to the power 3x dx, and that is going to be equal to u. What is our u here? U is x squared, and then v, we have found e to the power 3x over 3, and then minus the integral of v is e to the power 3x over 3, and then du, we have found 2x dx, and this is going to be equal to x squared e to the power 3x divided by 3 minus 3 and 2, these are constants, so I'll remove 2 over 3 because it's a constant, and then we're going to remain with integral, and I'm going to start with x, and then e to the power 3x dx. Now for this one, when we reach at this point, we need to continue doing by parts, because we can see the part which has got integral still has x in it, so we don't need to have an x. So we need to make sure that this is a constant, so we're going to take it again for a second time. So what I'm going to do is, again, just for this one, we are going to say let u in this case is going to be equal to x, and then dv is going to be the other portion, which is e to the power 3x dx. So getting to differentiate u, du is going to be equal to dx, and then we are going to integrate both sides to make sure that we remain with v. So v is going to be equal to e to the power 3x divided by 3. So therefore, again, the integral of x squared e to the power 3x dx is going to be equal to x squared e to the power 3x divided by 3 minus 2 over 3. Now, to integrate this portion which is here, we again use by parts. Remember the formula, uv minus integral again. So u in this case is x, v is e to the power 3x over 3, and then minus integral again of v, which is e to the power 3x over 3, and then du. What is du? Du is equal to dx. Okay, so that is what we're going to have. Now we'll continue working out this one, and this is going to give us x squared e to the power 3x divided by 3 minus 2 over 3. We have got x e to the power 3x over 3 minus, this is a constant, so I can remove it outside the integral, and we're going to have integral of e to the power 3x dx. So that will be x squared e to the power 3x divided by 3 minus 2 over 3, and then we have got x e to the power 3x over 3 minus 1 over 3. Now we get now to find the integral of e to the power 3x. So simply differentiate the 3x, that will give us a 3. Okay, so that is going to be e to the power 3x, and then get to divide by the same 3, and simply add the constant c. So at this point, we'll simply get to simplify this, and that will be the integral. And this is going to be equal to x squared e to the power 3x over 3 minus 2 over 3. So inside we've got x e to the power 3x divided by 3 minus e to the power 3x divided by 9, and then plus a constant c. Okay, so there is something that is common on everything which we have here. I can simply distribute this part to everything that we have, and that is going to give us x squared e to the power 3x divided by 3 minus, that will be 2x e to the power 3x over this 3 times this 3. Instead of me writing 9, let me just write 3 times 3, and then this negative and the negative becomes positive, so that will be positive, and then that will be 2 e to the power 3x, and then divided by this 3, also multiply with the 9 there, so I'll just say 3 9, and then plus a constant c. So at this point, I can factorize out what's common, because we can say there are a lot of things which are common here. So which are those which are common? On top, we can say for everything there is e to the power 3x, and then down for everything we have got a 3. So for the first one, if we remove that, we are simply going to remain with x squared. For the second one, we are going to remain with a 2x over 3. For the third one, we are going to remain with a 2 over 9 plus a constant c. We can leave it here or we can merge it as a single fraction where we get to, of course this is over 1. I can merge it as a single fraction or I can leave at that point. So let's just try to merge it as a single fraction. So that is going to be e to the power 3x divided by 3. Now since the highest number in the denominator is 9, I'll multiply everything such that the denominator is going to have a 9. How can I make a 1 a 9? I need to multiply by 9. So on top I'll multiply by 9x squared, even down by 9. And how can I make a 3 9? I need to multiply by 3. So on top I'll multiply by 3, that becomes 6x. Down I'll also multiply by 3, that becomes 9. And then the other one I'll just write it the way it is. And that is going to leave e to the power 3x divided by 3. And then we are going to have 9x squared minus 6x plus 2, everything over 9 because 9 is common in the denominator, and then plus c. Another way we can do it is just leave this as e to the power 3x over, multiply this 3 by this 9, that is going to be a 27. And then in the brackets we're going to have 9x squared minus 6x plus 2, and then plus a constant c. So that is going to be it. Let's consider this one. We want to evaluate the integral of natural log of x. Now for this question, of course when you're using by parts there should always be a product. There should be a u and a dv. Now natural log of x is multiplying with what on this one? Well, even if we can't see a 1, it is multiplying a 1. And so what we're going to do is we're going to get a 1. Now which one should be dv, which one should be u? Remember how we said u should be something that you can easily differentiate, dv should be something that you can easily integrate. So we can't make this as dv because we can't easily integrate it. That's the question that we've been given. So u in this case is going to be natural log of x, and then dv is going to be equal to what? A 1, but dv is always related to dx, so it will be 1 dx. Of course we can't see a 1 there, but it is there. So to be able to find du is going to be, how do you find the integral of a natural log? Simply differentiate whatsoever this one, sorry, not integral but the derivative. Simply differentiate this one whatsoever it is, so the derivative of x is a 1, and then divide by itself. So simply add the dx. And then to be able to find v here, we're going to integrate everything. So integrate here, also integrate there. Now we already said the integral of dx is x, or the integral of 1 with respect to x is x. That's the same thing. So we now go to the formula. The integral of u dv is equal to the integral of uv minus, sorry, not the integral of uv, but uv minus the integral of v du. So this is the integral of natural log of x dx, and that is going to be equal to, what is u in this case? U is natural log of x. What is v? V is x. So we get to multiply those two. So that is going to give us x natural log of x, and then minus integral. What is v in this case? Well, v is x. And then what is du? Du is 1 over x dx. And this is going to give us x natural log of x minus this, we can see can cancel out with this, and that will just give us the integral of dx, and that will give us x natural log of x minus the integral of dx is simply x. In other words, what's the integral of 1 with respect to x? That is just x plus a constant c. If we want, we can factorize out x here because it's common, so the answer can be x open brackets natural log of x minus 1 and then plus a constant c. So that is going to be it. Let's consider question number 6. Want to evaluate the integral of natural log of x squared. So same here, u is going to be natural log of x squared. If we are using new substitution, we just get what is inside, but this is by parts, get everything, and then dv is going to be equal to what? A 1 dx. So to remain with, to find du here, du first we are going to use the product or the chain rule. That's a power rule. We get to drop these two, that will be 2, and then natural log of x, we reduce the power by 1, it becomes power 1, and then now go to what is inside. The integral of what is inside, we get to integrate x, that will give us a 1, and then divide by the same x that we differentiated. So just add dx, and then to remain with v here, integrate both sides. The integral of 1 dx, that is simply x. So now going back to the formula, the integral of u dv is equal to uv minus the integral of v du. So this is the integral of natural log of x squared dx. That is going to be equal to u, in this case, is natural log of x, and that is squared. And then v is x. So I can simply put the x in front there because they're multiplying. And then minus the integral of v. What is v here? It's x. And then what is du? Well, we can see du is this second part which is here. So that is 2 natural log of x divided by, there's an x in the denominator, and then there's also dx there. So you can see that this x and that x is going to cancel out, and so this will give us x natural log of x to the power 2 minus 2 is a constant. I can remove it outside the integral, so that will be 2 integral of natural log of x dx. So since again we have got the integral of natural log of x, we are going to perform integration by parts for one more time. And in this case, again, u is going to be equal to natural log of x. Now we are dealing with only this part. And then dv is going to be a 1 dx. Therefore, du is going to be equal to 1 over x dx. And then v will be the integral of 1 with respect to x, which is simply x. And so this will give us x natural log of x squared minus a 2. Now we take the integral of natural log of x, that will be uv. U in this case is natural log of x times v, which is x. So that will be x natural log of x, and then minus the integral of v. V is x, and then du. Du is 1 over x dx. And what are we going to get from there? So that is going to be x natural log of x to the power 2 minus 2, and then that is x natural log of x minus, so this one and this one will cancel out. So just remain with the integral of 1 with respect to x, and that is x. So get to add the constant c. So we can from this point just get to distribute the 2 which is outside, so that will be x natural log of x to the power 2 minus 2x natural log of x, and then it becomes positive 2x because this is a negative 2 times negative, that becomes positive, and then plus the constant c. Well, we can see something that is common amongst these, and that is an x. We can factorize out an x, and then what we are going to remain with. So that is going to be natural log of x squared, and then minus, here we are going to remain with 2 natural log of x, and then plus a 2, and add the constant c. So that is going to be it for this one. Okay, let's consider the last one in this practice, the integral of x to the power 4 natural log of x. So again, it is very difficult for us to set dv being equal to natural log because we don't know the integral of natural log of x. So u is going to be natural log of x. Then dv is going to be equal to x to the power 4 dx. So du is going to be 1 over x dx. And then v is going to be the integral of x to the power 4. What's the integral of x to the power 4? Just add the 1 to the power, that becomes power 5, and then divide by the same 5. So we get to write the formula integral of u dv is equal to uv minus integral of v du. And this is the integral of x to the power 4 natural log of x dx. That is going to be equal to u, in this case, is natural log of x. And then v is x to the power 5 over 5. Minus the integral of v, which is x to the power 5 over 5. And then du, we can see du, that is 1 over x dx. And this is going to give us, we can just write this in front, that is going to be x to the power 5 over 5 natural log of x minus, I can remove 5 because it's a constant, it is in the denominator, so that will be 1 over 5, and then integral 1x will cancel with 1x there, that will just be x to the power 4 dx. So from this point now we can proceed and get to integrate the other side. So that will be x to the power 5 over 5 natural log of x minus 1 over 5. What is the integral of x to the power 4? That will be x to the power 5. We add the 1 to the power and then divide by the same power. Then just get to add the constant c. So this is going to give us x to the power 5 over 5 natural log of x minus x to the power 5 divided by 25 and then plus a constant c. Again, that is the answer, but we can just factorize out what is common. We have got x to the power 5 common, we have got also a 5 in the denominator common. So what remain here is natural log of x, what remain on the other one is 1 over 5, then plus a constant c, of which we can express it as a single fraction, that would be x to the power 5 over 5. This is the same as over 1. So 5 multiplied by natural log, that would be 5 natural log of x minus 1 over 5. We can as well write it like this and then plus a constant c. Therefore, that is the answer for this question. Well, thank you so much for having been patient until the end. If this video is helpful, you are going to do well to support by subscribing and also liking, also sharing the video. Enjoy your day.